Hi, in this video you will learn how to configure and build an Envoy image and push it to ECR. This operation will let you run a reverse proxy on your ECS task that will be encrypting traffic between the load balancer and ECS. So if you follow this tutorial, your infrastructure should be looking something like this. We have our beautiful ECS cluster with one service named test service that has two tasks. Let's call it task A and task B. We also have two repositories, one for the application image and another one for the proxy image. But if you go to ECS and check the status, you will see a lot of failures in the tasks with the following message: cannot pull container error. I think this error is pretty self-explanatory, and the reason for this is that these two guys are empty. We have not uploaded anything there yet, and in this video we're gonna fix it. Once we've built and pushed our images, the new tasks, will be able to pull these images, one from the application repository and another one from the Envoy repository. And then it will all work. This is the last bit we need to do to encrypt our traffic between the ECS service and the load balancer. If you remember, in the previous video we have created these files to generate our self-signed certificate. So let's put them in a separate directory named certs. Okay, this error is expected, and then let's list the files. Brilliant. Actually, we need only two of them, the public certificate and its private key, but let's keep the rest just for now. We can always remove them later. So I think the best way to set up the Docker images would be to start from the application container, and the very first step would be to create a file. I'll be creating a Python file that will be rendered by our app container. So let's do that. Let's call it service.py. But let's quickly go through the file line by line. So first we import a Flask, which is a lightweight Python web framework. Then we also need to import Socket, which is a Python networking module to help us to expose our IP address here. And then we initialize a Flask app instance. Then we have this function to return an IP address of the task that will be used here. Then we define our endpoint, and then finally we run the application on port 8080, making it accessible to the host or other containers, namely the Envoy container. Debug is set to true to help us to debug in case of any troubles, but of course if you run it in production it should be turned to false. And that is it. Quite simple, right? So let's just save it. The next step is to create an image definition for the container that will be hosting our Flask web application. Let's call it Dockerfile app. And it should have these contents. In this Dockerfile, we are saying to set up a minimal Python environment using Alpine Linux and install all required packages. But let's go line by line. Here we say to use the official Python Docker image, and then the Alpine's package manager is APK, so we have to use that to update and download our packages. Then we install all of the required libraries. We create a directory named code, and we copy this Python file we created earlier to the directory. Then we declare that the container listens on port 8080, and finally we say to launch our Flask application using Python 3 when the container starts. So that looks good. We can save it. Okay, that's enough for the application image for now. So let's switch our focus onto the Envoy proxy image. And before we create image definition, I would offer you to start with the config file. This will help us to serve HTTPS traffic, to proxy it to the local backend service, the one that we've created just now, and also use TLS certificate, of course. And finally, it would be beneficial to impose a connection limit. So let's start creating our config YAML file. So let's go back into our terminal and create a envoy.yaml file. And this will be our config. As always, of course, you don't need to retype all of this. I will add the full configuration to the video description. So now let's go section by section to try to understand what we are doing here. Okay, so the first section is overload manager. Do you see this line saying max active downstream connections that is set to 1000? This one prevents Envoy from accepting more than 1000 active downstream connections. It helps mitigate DDoS attacks or something less harmless as load spikes. Then, under the static resources, we set our listener on all interfaces, and we tell it to use port 443, which is the standard port for HTTPS. And then next you will see our TLS configuration. So we are presenting our certificate, which is my -aws-public.crt file, which we've created in the previous video. And then we also load our private key to prove the ownership of the cert. So in our case, the ALB will be the client and will be initiating an HTTPS connection to Envoy. And of course, the load balancer expects Envoy to behave like a standard server, to present a valid certificate and to complete the TLS handshake. And yeah, the handshake cannot be done without the private key. So that's why we are loading it as well. The next section that we have here is filters. We have one network filter, which is HTTP Connection Manager, and it manages HTTP traffic. Once a client connection is accepted and decrypted, the HTTP Connection Manager will pass the HTTP request, decide where to forward it. There's a spoiler alert, it will forward it here to the local service. And then finally, it will forward the response back to the client, which is our load balancer. So let's quickly go through the parameters of HTTP Connection Manager. Here, we tell Envoy to use the v3 version of the Connections Manager API. Then we say, Envoy, you need to detect whether the request is HTTP 1 or HTTP 2 automatically. Then we say that all stats generated by the Connection Manager should have this prefix. And then we define the root config. And here we say, okay, all requests to all domains, just take them and forward them to this cluster, local services. We are going to talk about it in a second. And lastly, under filters, we have HTTP filters. Actually, we have only one, which is Envoy router, and it is required to perform routing, so it's mandatory. But you can add more filters if you want around authentication or create your custom ones, but we don't need it here. And our local service cluster defines the backend service. All you need to know that the routes are forwarded to the local host on port 8080. The other information is not really needed now, like load balancing policy and DNS resolution. We're not using any of this for now, but let's keep it in case we'll want to edit later. Lastly, admin block enables Envoy's admin interface. It's good to have it for stats or debugging in the future. So let's save the file. Okay, next thing we need to do is to create a shell file that will be executing, loading, I should say, our envoy.yaml configuration file and execute this shell file in the image definition. So let's do that. It's a very short and simple script. It starts the Envoy proxy using this specified configuration file. And yeah, it will be used as the entry point. So let's save it. Great. Now we are all set up to create our Docker image definition for the Envoy proxy. Let's do that. But before that, let's double check that I'm not lying. Yep, we have our source directory, Dockerfile app, amazing. Dockerfile-proxy, I think that's a good name. And let's edit it. And now paste this code into the image definition. So let's break it down. At the very top, we are saying that we want to use Envoy proxy version 1.3 as our base image. Then we download a bunch of Python dependencies. This is needed to install AWS CLI. AWS CLI is not really needed or used by our image, but it might be useful in the future if we decide to, if we'll need to debug. Then the next thing is we copy the files and directories that we created earlier to these directories. Don't worry if these directories do not exist, the copy command will automatically create them. Then we give execution permission to start Envoy shell command, we expose HTTPS port, and we set start Envoy as our entry point. So that's all good. Let's save and exit. Great. We have everything to start building our images. So let's start with the app image. This is the command that we need. Of course, prior to executing it, you need to install Docker and start Docker daemon. Please export these two variables, AWS account ID and AWS region. I believe you know how to do it. And yeah, this is the tag that we need to use to be able to push it to the app ECR repository later. And here we specify the file that we're going to use to build this image. So yeah, exciting. Let's press enter. That worked brilliantly well. So let's do the same for the proxy image now. And the second image is built successfully as well. Well done, so it's time to push it. As always, we're gonna start with the app image first. So this is the command that we need, docker push, and then our repo URL. Oh, of course, prior to that, we need to authenticate Docker to our ECR. Let's do that. This command should do the trick. Login succeeded. Nice. Took some time. And let's go back to our original command. It's getting there. Let's do the same for the proxy. So far, so good, right? And as you can see, the proxy image has been uploaded as well. So let's go to the AWS console. Okay, here we are at our ECR repos. You can see these two beautiful repositories. Let's go to the first one. Boom, and we see that the image is there. Nice. And let's check the proxy. Same thing. Well done to us. So now let's go to the ECS. Okay, here you can see that our tasks were like keep restarting with this error that we talked about before. But now we should be able to see new tasks that don't have this error anymore. Now you'll see that the new tasks unfortunately fail as well. So let me quickly show you the logs. Both containers show the formatting error, and most likely the reason is because I was building it on my Mac M1 and ECS expecting AMD 64 architecture. So yeah, this happens quite a lot when you're building locally. That's why I would advise you, and normally the way I do it, is to build the images via your CI/CD pipeline, for example, GitHub Actions. But let's try to debug it together. Now we're going to push a new version of the image, now built for Linux AMD 64 architecture. So let's do that. That was a green run for our application image. So I have launched, same one as you can see here for our proxy image. Should be fine as well. So we had two successful uploads to our ECR repos. So let's check in the console. Yep, as you can see, the app repo has two images now, and it should be the same for the proxy. That's the case. So let's go to our ECS, and well done. What we can see here is that both tasks are running. So my assumption about architecture misfit was correct. And the next thing we can do is just check the actual URL. If you remember, I was using DNS name m-computing.org for my website, and the endpoint for our test service was just service. So let's give it a go. Brilliant. We can see our message. Let's refresh it. Yep, we've been navigated to the second task. So our load balancing works as expected. Well, that is pretty much the end of this tutorial. Thanks very much for watching it. please don't forget to like and subscribe. But there will be one more episode where we'll be testing the encryption between ALB and ECS. That's right, we don't take anything for its word. We're gonna check everything. We will be using TCP dump tool to capture the traffic and see if it's encrypted. So yeah, as always, see you in the next video.